Well, we've got this situation where the frogs have been growing exponentially. By that, I don't mean one single frog is getting bigger and bigger, but exponentially means that the population could be modeled with the PERT formula. And we first need to find out what R equals. So start with the beginning amount of frogs, that is the P. And then we also need to know the times. So this is a little bit outdated. It goes from 2005 to 2009. So that means T equals 4 years. And then the amount of frogs after that time is 104. So then substitute 104 for A on the left side. Then use P is 24 frogs. E is raised to R, which is what we're trying to solve for right now, times 4 years. Okay, so we will be using natural log, but before doing that, divide both sides by 24. And the fraction 104 divided by 24, I'll just leave it there. And on the right side, we just have E raised to R times 4. And then the next thing to do is take natural log of both sides. Natural log and E will cancel each other out. So on the right side, we only have R times 4. And then natural log, and just to be safe, I'll put it in parentheses, the 104 divided by 24. Then to solve for R, I just need to divide both sides by 4. And at that point, it's time to use a calculator. So go over to the calculator and find out what is the natural log of 104 divided by 24, which that needs to be in parentheses, and then divide by 4. So I'm going to be using 3 decimals, and that's going to be R equals 0.367. So the R is equal to 0.367. Okay, so that means that in general, our function is the amount of frogs will be the starting amount 24 times E raised to the 0.367 times T, where the T is in years. Okay, what's next? Let me go back to the question. And I need to see it a little bit better. Okay, the next part of the question is find the year and even the month when the amount of frogs will exceed 200. So if I set it equal to 200, or in other words, the P becomes 200 frogs, then I could solve for T. So go back down to my function and substitute 200 for the amount of frogs. 0.367T. And then basically we go through the same steps that we just did. Divide both sides by 24. And just leave the fraction 200 over 24 on the left side. And just like a minute ago, in order to eliminate the E, we will take natural log on both sides. So again, these two cancel each other out. We're left with 0.367 times T. And then there is the natural log 200 divided by 24 on the left side. And just divide both sides by 0.367. And that is what T is going to equal. So hop on over to the calculator. And this time find out what is the natural log of 200 divided by the original 24 frogs, and then divide that by the 0.367. So that's an easy number to remember, 5.777. So T equals 5.777. So the 5 means 5 years later. And then you can take the decimal part, 0.777, and since there's 12 months in a year, that will tell us which month it is. So I just need a 0.777 times 12. A 0.777 times 12. So that would be the 9th month. So 9th month is September, so that's going to be September. And if you even wanted the days, you could take the 0.324 and multiply with however many days there are in September, and you could even find out that it would be September 9th. Okay, but with this one, I just asked for the year. So this is September because that was a 9. And then 5 years later means we have to go back to the beginning of the problem and find out when this story started. I think it was 2005, wasn't it? So the story started in 2005. So if you go 5 years later, that's going to be 2010. And obviously I need to update this because 2010 was a long time ago. So that would be 5 years later means 2010, and then September. In English, we usually put the month first and then the year. So September 2010.